The next concept and terminology that we need to know is conversion. So conversion, the definition is that conversion is the fraction of feed or some key material in the feed that is converted into product. So the key material here, some key material of the feed or is usually referring to our limiting reactant. So most of the time when we are talking about conversion, we are talking about how much of our limiting reactant is converted into the product. Because most of the time, not all of the reactant is reacted. The percentage of completion is not 100%. So far we have been looking at that everything, whatever you are putting in, everything is being converted, right? But sometimes only 50% is converted, only 70% is converted. So we need to find what is the conversion factor. So this is the formula. Percentage of conversion is equal to mass or mole of the feed that is reacted. So how much of your mole of feed is reacted divided with the mole or mass of the feed introduced times 100, meaning that how much reacted you divided with how much you had initially. So I can also say here, if I were to write over here, it's also equal to mole reacted over mole fed to the system. So based on this one, if you don't have this times 100, okay, if you don't have this time 100, then it is known as fraction of conversion. If you put times 100, you have percentage of conversion. It's the same number, it's just that either you are putting in percentage or fraction. So if the question asks you what is the fraction of conversion, don't times with 100. If the question is asking you what is the percentage of conversion, times with 100. Okay, so that is the first way you can find your conversion. The second way is that conversion can also be found using your extent of reaction. So the percentage of conversion again here is equal to extent of reaction that actually occurs divided by the extent of reaction that would occur if complete reduction took place. Meaning that this is what is happening and this is the theoretical where your conversion is 100%. So you have two formulas you can use to find your conversion. And the same thing here, if you have percentage of conversion, you times it with 100. If you are finding fraction of conversion, don't time with 100. So that is the only thing you have to know about conversion. So let us look at example number 5. So in example number 5, given the reaction is that you have C7H16 is reacted with 11 oxygen to produce 7 carbon dioxide and 8 H2O. So let's say that if you have 10 kg of C7H16 react with oxygen and produces 4.4 kg of CO2, what is the percentage conversion of C7H16? Okay, so if we were to draw our flowchart, so we have here C7H16 and you are adding it with oxygen O2 and you will get, this is a combustion reaction, so you will get CO2 plus H2O. Okay, so this is your reaction. Now we were given that we produce 4.4 kg of CO2 and the feed was 10 kg of C7H16. So we were given these two information. Now, if you read the question, it is asking us what is the conversion of C7H16, meaning that in a way we can say that this is our limiting reactant. We have oxygen here is our excess reactant. So because most of the time we will be focused on conversion of our limiting reactant. Even though the question is not stating, but sometimes you can assume that this is your limiting reactant. But now we want to find how much of this one is converted based on how much CO2 is produced. So first of all, we are given everything in kilo, so we have to change from mass to mole. So I will just tell you the mole of C7H16 I get is 0.1 kilomole. Okay, and the mole of CO2 that I can get is from based on this 4.4 is 0.1 kilomole. Okay, so you can go back and try to find how do you get 0.1 kilomole here. Now I say that in order for me to know how much, so the total amount of mole of C7H17 I have is 0.1 kilomole. But I know that 1 mole of C7H16 will produce 7 mole of CO2, right? So this one I have known that based on my chemical reaction here. 1 mole of C7H16 will produce 7 mole. But now I know that I have produced 0.1 mole of CO2 here. So I need to know in order for me to produce 0.17 of 0.1 mole of CO2, how much C7H16 that I need to react. So you can use this, again you can use the stoichiometric coefficient and the ratio to find your value of mole of C7H16 reacted, or you can also use extent of reaction. So let's say I use the stoichiometric ratio. So 1 mole of C7H16 I divided with 7 mole of CO2, and I know that this is my ratio, but I know that I have produced 0.1 kilomole of CO2. So everything must be in kilomole. This one also kilomole. So I know that I can get a value of 0.0143 kilomole of C7H16. So this is the amount of C7H16 that I have used. I have reacted with oxygen, which is excess, to produce 0.1 kilomole of CO2. Now that I've known that amount of reacted and I know that amount of fat, I can easily find my percentage conversion. So percentage conversion is equal to mole reacted over mole fat. So my mole reacted here is 0.0143 divided times 100 because I'm looking for percentage, divided by mole fat, which is 10 kg of C7H16, which is 0.1 mole. 0.1 times 100. So I will get my conversion is 14.3%. So this is my conversion, meaning that to say that out of 0.1 kilomole, I'm only using 14.3%. So meaning that if I were to do a complete label of my flowchart here, I must also put here C7H16 that was unreacted with the O2. Why? Because I know that my oxygen is my excess reactant, meaning that I will definitely have more oxygen than my C7H16 here. So that is the first way for you to find your conversion. The second way is that you can use your extent of reaction. So extent of reaction, if you are using extent of reaction, you know that you have to find the actual extent of reaction divided with the maximum or theoretical extent of reaction. So in order for us to use that, so we first of all we have to know the extent of reaction that is actual. Now how you decide that is by looking at this one here. So you have to understand when you have a chemical equation, chemical reaction, the amount of product produced will be related to your extent of reaction. So as we looked at in our previous class, we said that extent of reaction, the definition is that how much reaction has occurred. So based on how much reaction has occurred, that is how much product you can form. So if I want to find my actual extent of reaction, I can use this value here. So my actual extent of reaction, I can say here, I just write actual A is equal to based on the CO2, meaning that initially, finally, the final mole is 0.1. Initial, I had no CO2 in my system, so minus 0 divided by, and my stoichiometric ratio for my CO2 is 7. So I can get here 0.0143 kilomole. And then my theoretical extent of reaction, I can say that I can use my mole of C7H16, meaning that I can, if let's say my conversion is 100%, 100% meaning that final at the end of the reaction I have 0, and then initially I have 0.1, and then I divided with -1. So I can get here the value is 0.1 kilomole. So now that I've gotten the actual and the theoretical extent of reaction, the same thing here, I can use percentage of conversion is equal to the actual extent of reaction 0.0143 divided with 0.1 times 100. So I will still get a value of 14.3%. So this is how you solve it by using extent of reaction.